Okay, let's get started. Hi everyone, and thank you for joining us today for a webinar hosted by Nicolas, Senior Solutions Engineer at HashiCorp. In this webinar, Nicolas will demonstrate how an existing application can leverage advanced features of OpenShift, Vault Dynamic Secrets, and Red Hat Single Sign-On to enhance its security by only modifying its configuration. We will then spend the last 10 minutes of the webinar dedicated to live Q&A. This webinar is recorded, and the recording will be made available after post-processing, usually within a day or two. I'll email it all to you after the webinar. If you think of a question during the webinar, feel free to pop it in the questions box in the GoToWebinar panel. We will then get to them during the Q&A session at the end. With that, we'll go ahead and get started. Over to you, Nicolas.
Hi, Emma. Thank you for the quick introduction. Good morning, everyone. Happy to be here doing this webinar and hosting this webinar. So today we are going to speak a little bit about how you can secure your application without or with only some change inside your code to give on your application a lot of security. But let me introduce myself first. So as Emma said, I'm a solution engineer based in Paris, in France. You can probably hear my accent. So I joined HashiCorp like 1 year ago now. So I spent 20 plus years on IT, mainly focused, on cloud virtualization, automation, and DevOps, of course. I'm not a developer yet, but I'm working hard on it, and I'm gonna, try to be the best to do that. So, what about this talk? The main objective here is, to demonstrate a way on secure on how to secure your application when the application was not integrate security at the very beginning. So here, the main use case will be to demonstrate a Java application, so using Spring Boot, without any security, and we're going to start to use different HashiCorp tools and different mechanisms like Keycloaks or Red Hat SSO, that's the equivalent on the open source side, to demonstrate how we can add security without touching the code of the application. So that's pretty useful when the application was not, as I said, built with security in mind at the very beginning. But that's very important. So I want to thank also Laurent Boudou from Red Hat, because he helped me a lot on building the demos. I did everything related to HashiCorp, and he did everything related to Kubernetes, OpenShift, and Red Hat SSO stuff. So who should be interested in that specific talk? First, developers. Why? Because they can understand how to add security in their application. So as I said, we don't have a lot of things to do on legacy application to add security, but here we demonstrate how to, with few lines of code, what we can do and what we can add regarding authentication and authorization, for instance. So that's the main goal of Keycloak. Security teams, because with Vault, in fact, with our tools, we can help security team to give a centralized way of managing secrets and accessing it via API. So it's pretty easy and automatic to integrate secret access through Vault on the application. And that means that you can, break the boundaries between security teams and other teams inside the companies. Network teams, same thing, because even if we speak about only secrets, you also have another thing that is pretty new and that we call service segmentation or service mesh, and we're gonna, introduce that that stuff during the demonstration, because it's mainly demonstration. I'm gonna go very quick through the agenda. It's mainly to explain, okay, where we were or where we still are, and what is the cloud native patterns, and what does it mean in real life, and the demo time, and what we do next. So back in the days, we were in a trusted zone. That means that mainly in on-premise static infrastructure was built. Everything was owned by the companies in their own DCs. So the first principle was everything in DC is trusted. So we don't have to take care about everything inside the DC. We have to take care and secure everything related to external world. So that's why we have kind of we have firewalls and perimeter firewalls to secure the applications that we host inside to the outside world, but we don't have a lot of security inside, in fact, the data center. Why? Because it's trusted. So also on that part, we also have kind of monolithic application where everything was built on a big monolithic. We use waterfall deployment and development workflow. And every time you want to add something or new features in the application, you have to change the code, and you have to change the codes of the whole application. So it's not really agile on that way. And we think at that time that virtualization was kind of agility, because with the virtualization, you can deploy new VMs very quickly, like in 5 minutes, instead of deploying bare metal server in days or weeks. But it's still not that agile. Regarding the monolithic application, as I said, it is, and because it still is, a big piece of code. Every new features need 6 months. Every time you want to add something, you have to follow the waterfall principle. So it takes time, because that's the way everything was built. Everything happens in memory, or only with one or two other services, like a database or like something else. But you don't have a lot of services that talks to each other. So in terms of communication, it's pretty easy. You just have to secure the access to the application, and everything related to the application regarding the communication will be inside the application. So it's quite easy to secure, but it's not easy to scale, because if you start to scale it, you have to think about clustering systems, and it becomes not easy to scale the application. Regarding the perimeter security, as I said in the previous slide, everything was trusted except everything that comes from the internet. So it's pretty easy. You have a firewall, you have some DMZ or specific VLANs that you have inside your network, and the only thing that you have to use and you have to take care of is the IP of the VMs. Why? Because you don't change or you don't replace the VM every 5 or 10 minutes, because you don't have to do so, because it's long-lived services. So you rely on IP. But as I said earlier, it's not very agile, because if you think about the cloud, for instance, you can't rely on IP, because you don't manage IP. You want to manage a name, and you want to manage like service name, and we're going to go through that after. Regarding the network, because as you can understand, regarding the logic I put in my slides, so you start with the application, monolithic application, perimeter security, and you have another thing is the network. So most of the time, what we see here in the more advanced data center regarding network, you have kind of spine leaf network. So you can scale. It becomes agile with SDN, but it's really hard to maintain, because you have a lot of things to do. You have a complexity at the network layers that you have to manage. And as I said, also, everything is based on IP. Everything is based on that. So it's not easy to maintain, and it's quite easy to scale, but it costs a lot of money to do that. So if we think about the cloud native pattern, so what does it change? Of course, everything now, if you think about the 12 application factors, the yeah, 12 factors applications. That's more correct. Everything is based on something that we call microservices. So we break the monoliths, we spread all the services inside the monoliths to new microservices, so based mainly on containers. So the containers are, of course, by nature, had short-lived, because here the main, the main interest in that is that you can change the features, because the features now is a microservices. You don't have to change everything, and you can use a new way of doing things, of developing things, like circuit breaker and stuff like that, to test the new version of the features that you have developed on the new containers, and change, and change the routing and network to go through the new version of the features when you have validated it. Of course, by nature, it could be deployed everywhere. When we say everywhere, it's not only on-prem, it's mainly on hybrid cloud, at least. So like on-prem and on Azure, but mostly now on multi-cloud. So it means on-prem, AWS, Azure, GCP. And of course, if you use that new pattern, it's completely different than what you have in the past regarding the way you did things with VMs and even bare metal. So of course, everything related to that needs to change the mindset regarding security and network, because, as I said, everything is dynamic. So when you say dynamic, of course, AP is not dynamic at all, or even if you think about DHCP, but it's hard to maintain rules and firewalls and stuff like that. And it's the same thing for the network. So as I said, the microservices pattern, each part of the application becomes now a microservices. So that means instead of having a monolith where all the communication happens directly inside the application, you have to think about the traffic generated by all the microservices that you have to manage inside your infrastructure. You gain like of velocity regarding the way you develop and deploy new features on your application. You can develop and deploy new features like every minute or at least every days. So it was completely different. And everything is integrated in the continuous integration and deployment systems. So everything is automated. That's why, it's not easy now to manage everything by hand like it was in a traditional infrastructure. Regarding the multi-cloud, as I said earlier, you're moving from a trusted zone to a zero trust zone. That means first you had your own data center, everything was managed by you on your infrastructure, but now you are deploying sensitive data, sensitive application to the cloud because you have to, because you want to do that. So of course, because you don't know who is in charge of the different DCs and all that stuff, you can't manage the infrastructure layer, you can't manage the network, the physical network and stuff like that. You are moving to a zero trust stuff, and you have to take that into account. And that means that you cannot rely now on IP-based security. You have to change the mindset also regarding that. Same thing for the communication at the service levels. So of course, because you moved from a monolithic application to a microservices kind of application, you have more traffic regarding east-west traffic. So that's why you need to rely more on load balancers to do that, to do the load balancing. And the thing is, a traditional solution like load balancing can scale without the high cost of buying new load balancers for every services that you want to load balance for any other services to communicate with. So that's why everything is based on service discovery, And of course, you can't use also the IP-based rules to allow communication between different services, because as I said, IP change every time, every seconds or every minute. So you cannot, maintain like security rules on firewalls. If you use IP-based rule, you can do that. It's not easy. So what does it mean it in real life? Of course, that imply a lot of things. First, we move from a waterfall deployment to agile development. So first, we break the monoliths. We had a more CI/CD solution, and it is Earth of the development systems and the Earth of the application deployment. So everything is in a pipeline, and that means that every time you want to deploy something, it's pretty easy. Everything is as code, everything is automated, so you can deploy everywhere very rapidly. You have to also use container or resource orchestration like Kubernetes or OpenShift. And of course, as I said earlier, security and network must be based on services instead of IP and name and IP, sorry. But yeah, of course, why we do that? Because as I said, we had a lot of changes inside that. So when we moved to a monolith for microservices, secret management become a big concern. Of course, you can see every time a lot of developers putting like sensitive variables inside their code, pushing that into a Git repo where everybody can have access to it, or it's in clear text in the code or in a variable inside the pipelines, and you can't do that anymore because, as I said, you want to deploy everywhere, so you have to take care of the secret management and how to do that. So to do that, and for the demo, we used, of course, Vault to do that. We will use different services. We will use PKI as a services to secure the ingress routes, to communicate with the pods, with the services. We will use Kubernetes out methods to authenticate the pods and to give them access to Vault and their specific secrets. We will use two different secret engine. We will use KV secret. So even if PKI is a secret engine too, we will use a KV secret store for static values, because we're gonna, through the journey, we're gonna go to different steps, and we will use dynamic secrets from MongoDB, and we can also do auditing, of course, with Vault to audit everything that happens on Vault and everything that everyone that want to connect, or every application or everything else. But wait, in the network, it's exactly the same. We have to change things. We have to, had a more agile way of managing that new microservices and that new way of doing things. So we have to do that. We use HashiCorp Consul, and we're going to be based on service discovery because that's the main role of Consul. We're going to use also service access graph and Consul Connect to implement like service mesh or service segmentation inside Kubernetes OpenShift. For me, it's pretty much the same. And we're going to use and demonstrate the Envoy integration and other stuff like certificate authority, because we're going to use MTLS connection to secure the communication between the services, and everything will be automated by HashiCorp Consul regarding the control plane and the data plane. That's the main thing regarding that. So now I'm gonna move to a demo. So to do that, I'm just gonna explain pretty quickly the workflow. So here we really want to start from the very beginning. So like you're in production, you have an application and it works today in a VMs or somewhere else, and you want to move it and to do kind of lift and shift to a Kubernetes platforms. And so to do that, first you want to start to secure the access to your routes, so using HTTPS and certificates. After that, you're gonna want to think about, okay, I secure my root, so I have HTTPS, but now I want to add authentication and authorization on my application, so using Keycloak or any other SSO systems or something like that, or SAML systems. And as a next step, because you want, as I said, maybe you don't want to do a big bang and you want to go step by step. So you had another step, and we are going to introduce secret management. So we're going to use, in fact, Vault Kubernetes auth method, static secret management as a starter to move the secret from Kubernetes to Vault and use something that we call init containers to authenticate to Vault, grab the secrets, and use it as a variable inside my pod instead of having it in Kubernetes. It's more secure in a way that you centrally manage all your secrets outside of Kubernetes, and of course, it's highly secure. After that, we're going to move to a even more secure way of doing things. We're going to move to dynamic secrets. So where the application, every time the pod starts, it's gonna connect to Vault and authenticate to Vault, grab a token, and start and ask for dynamic secrets. And when you do that, when you kill the pod or when you kill the application, it will revoke the secrets from Vault from the database. So that's also another thing. And at the end, we're going to introduce the service segmentation. So pretty quickly here, we're going to use something called Cert Manager. So just to be pretty clear, I use Terraform to automate everything because I didn't have time to, I don't want to spend time typing a lot of command. So here, what we're going to do, we're going to configure and deploy Cert Manager on Kubernetes or OpenShift, whatever. And we're going to use and configure Cert Manager to automatically connect to Vault. And every time a new services, a new application with a specific annotation in the configuration deployment gonna start, it will gonna ask for a specific certification. So let's do that. Let's move to a demo. So just to show you here, I have a Vault. It's totally empty. And now I have some, let me show you that. I have some containers, some pods running on my Kubernetes environment. And now I'm going to start to deploy things. Just to show you the code, everything is on my GitHub if you want to do it. I did some README stuff to explain how it works. So here I'm going to do a lot of things. I'm going to configure cert management. I'm going to configure Vault, creating the different backend needed for PKI as a services. I'm going to deploy MongoDB and configure MongoDB, creating the secrets and stuff like that. Everything is generated automatically, the ingress routes and all that stuff. So if I do a plan first, just to show you what yeah, of course, I didn't remember that. Token. So give me 1 second. I have to restart my terminal. So I had an issue with that. Of course, don't do that in production. You don't want to have your root token stored somewhere. But here it's a demo environment, so it's not really an issue. Yep. So here, what I do, I just create environment variables to give access to my Vault clusters. Oh shit. Sorry, I did a mistake. Yeah. Okay. So what I do here, I'm going to add 29 new resources. I'm going to do a lot of things. So as I said, so now I can do an apply. So what I'm going to do, I'm going to configure Vault, I'm going to configure and deploy Cert Manager, and you will see more containers coming here. And the magic will happen regarding that. Of course, I hope, if the demo goes hard with me. Yeah, so here I'm starting to creating a lot of different pods. So Cert Manager, I'm using Elm resources inside my code to do that. And here, as you can see, if I do a refresh, you already have the PKI, so the root PKI and the PKI, the intermediate PKI used to, in fact, deliver as a services a new new certificates for every pod that need them. So now I'm done for the step 1. So here, what I have to do, I just have to go to certificates, grab the certificates, because it's a self-signed. So if I want my browser to validate the certificates, I need to import it. So PKI.pem. Okay, so that's my new certificate authority. So here, I have to move that. Yep. I'm gonna add preference, privacy security, view certificates, import PKI pen. Okay, open. Yep. Okay, so now I'm done. So what I need to do now is I want to deploy my application as a containers inside my Kubernetes environment. To do that, I'm going to use Fabricate, which is a development environment, but it's not, just use that. Oh, yes. So now I'm using it. Oh, so it's gonna bring my codes. Everything is here, and some things that I code secure. Yep, where is it? Let me show you the code. Secure fruits catalog, where I have all the code, my pom.xml files, because as I said, it's Java, it's Spring Boot, and I have all the configuration of my application here. And now, for now, I'm just using, kind of basic configuration. So during that time, let me reduce that to have something. Yes, so now you can see the fruit catalog application. It's not running yet, but it should be in a few seconds after some few things. Yes, so now it's running. So now if I connect to fruits.testlab.local, I have an application that is secure. Here I can have my more information. I can verify that I have my specific certificates created by Cert Manager through Vault via the PKI as a services. As you can see, it's verified by testlab.local, so it's my intermediate certificate authority. That means here that I have access and I secure the ingress route of my ingress routes. So here I can create things because I have the communication between MongoDB and the front end, which is Node.js and Spring Boot application. So here I can create things. So that's pretty easy. So here, that's what we did. We create and configure Vault PKI as a services. We deploy Cert Manager. We configure for every in fruits catalog. So we put the right, I'm gonna find my words. Yeah, the right annotation inside the deployment to ask a Cert Manager webhook to create new certificates related to my specific application. That's the first step. Now let's move to the second step. Here we want to add authentication to our app. So that means we're going to rely, in fact, on something that we call Keycloak or any other IDP, to enforce authentication between the application and a user. We don't want to have like everybody can do everything on the application. We want to manage that and to add security. So here I'm going to move to step 2. I'm going to do a TF plan again. So here, what I do, I'm going to deploy Keycloak. I'm going to do things and create roles specific to Keycloak, because Keycloak will also use HTTPS certificates. So it's also use a cert manager. And I'm going to do a lot of things regarding that. So I'm going to do TF apply. And here, as you can see, I have 2 more new containers. So Keycloak, it takes time to deploy, of course, because we need like to deploy a Postgre, and everything is running only on my Mac. So of course it takes a little bit of time, not that much, but that's okay. And because during that time, what can I show you? Here, I'm going to check out 2 my Keycloak branches where I had, in fact, a little bit of code regarding the integration with Keycloak. So here I put, in fact, if I do ls, do I see the right one here? Yep. Here I should see Keycloak somewhere. Yeah, here I see Keycloak, so I mentioned that I'm going to use Keycloak in my configuration, and I put also some new stuff here in not here. Oh, check web app. I don't remember where I put it, but I remember that I put Keycloak somewhere to declare that I need to use Keycloak in my configuration. So now I deployed Keycloak. So here I'm going to go to Keycloak testlab.com. As you can see here, again, I have created a specific certificates for the ingress route to my Keycloak environment. So it's also a new, in fact, if you go there, secrets, PKI int. Keycloak, as you can see, I have a new certificates created, and here I have all the certificates that I've created. Of course, the revoke stuff will be managed by Vault or even Cert Manager when the pod is crashed or is deleted, but that's also the main point here. So I'm going to go to the console just to show you that. So here I already configured stuff, and as you will see, I'm going to use kind of users. Everything is already had users. Everything is already configured automatically. Let me put an ID. Yep. Here, I verify and save. I go to credential. I'm going to create a new password. Reset password. Yes, change password. So now what I'm going to do here, because I moved to another branch to take into account the fact that I want to use Keycloak for the integration of authentication and authorization, I'm going to do again an MVN fabric deploy to deploy the new version, on my Kubernetes environment. So during that time, as you can see here, not yet, but I'm gonna have in a few seconds for the new pods to connect, to be deployed. During that time, after that, now it's starting. So here, because it's done, we also have something else to do, because we want to had the environment variables for mentioning keycloak URL to the new application deployment. So we do that to make it work. Yep. So again, of course, we redeploy the application. And in a few seconds, we should have authorization and authentication integrated in our application. It is running, not yet, because I don't want to show you the... Yes, it is working. So here, if I do a refresh, now I have the authentication redirection between my application and Keycloak. So everything must go through Keycloak to provide authorization. So I'm connected. And now I can show you that I still have access to my application. And if I go to web developers, where it was, web console, network, was it network? Yeah, I have to do here something. If I go there and I create a strawberry, for instance, and where we put Germany. Yeah. Here we can see that we had the authorization and the bearer token. Every time you do an API call or every time you do something, everything goes through the Keycloak authorization. And because you have validated your authentication, you can have access to it. So that's what we did for the step 2. We had, in fact, the authentication to our application without touching a lot of codes inside our application. Now the next step, and we are going to move again to Vault, because we used Vault at the very beginning for the PKI as a services, and now we're going to use Vault to store static secrets and to configure Vault to allow authentication method through Kubernetes. And we're going to do that now because I'm running out of time, so I want to go pretty quickly. So here I go to step 3. I have something to do first, which is a Terraform import, because my deployment already exists. It's just an update of my configuration. So here, what I need to do, I want to configure Vault with a KV store, a secret engine, create policies, and create the Kubernetes authentication methods to do that, to give access to the pod. And I'm just also configure a new deployment with an init container, which will connect to Vault with a service account token from Kubernetes, and connect to Vault, grab a token, retrieve the secrets, store the secrets in a mounted volumes, and give the secrets to the application. So to do that, again, TF apply. So as you can see here, now I have a new KV store. It was not present at the second steps. But here, what I want to do really is to move the secrets from Kubernetes, because even and OpenShift is the same. Because it's not the main goal for Kubernetes to store really sensitive data. And of course, sometimes if you have like external database where you want to connect external to Kubernetes or OpenShift, it's not really relevant to put that secrets inside Kubernetes, because it means the secrets are spread everywhere on many different platforms. The main goal here is to use Vault for centralization of every secrets. That's why we use, in fact, that to provide the KV store. So here, as you can see, so I have my KV, I have the fruit catalog, KV store. I have my password. I can see it because I use a root token. Of course, the pod doesn't use the root tokens. The pod will use a specific tokens and with a specific policy, which gives access on read for the KV fruits catalog MongoDB. And that's what we use to give access to the application. So now I'm not using anymore the secrets inside Kubernetes. I'm using the secrets inside Vault, and I'm using the Kubernetes authentication method to ensure that only that pod can access to these specific secrets. So I can show you that pretty quickly. TI, where is my, yep. Just to show you I'm not lying. If I do a bin bash, here I'm gonna go to cd deployment, what config, and here I have, of course it's a cat. Here, as you can see, I have the Spring Data MongoDB URI, which is modified by the user, the password, and everything is read from the configuration, as you can see here. In the step 3 of my demonstration, here, static secrets, fits catalog. Here we have an init containers, and the beauty of the thing is that init container only runs the first time you start the code, and it's done. After it's done, it's removed. So here you can see we are going to use a curl command, so we don't even have to use a big sidecar container to do that. Just a few commands and a very tiny container to do the static configuration. And here what we do, we create, in fact, the crates, and we configure it here to use it inside the application. So here, as I said, I get rid of the secret inside Kubernetes, but I still secure access to the secrets by using the Kubernetes authentication method. So I don't even have to think about, in terms of application, what kind of authentication I have to use. I just, in fact, put my application and configure it in my deployment configuration. So now, as a step 4, we're going to use and improve the security, because, as I said here, we work with static secrets. Static secret is okay as a starter, but if you want to have and if you want to enhance the security, dynamic secret is far better. What does it mean by dynamic secret? It's temporary secrets. It's only created when it's needed, and that's the main point here for that specific steps. So here, I can go out, I can go CD, I can go step 4. Yep, I have my dynamic secrets. Oh yeah, I have to do something first, because I have to retrieve the MongoDB admin password. So to do that, I have to go there. I do Terraform show. As I said, don't do that in real life. You don't want to have your MongoDB password in clear text stored somewhere. Here, I'm going to do nano parts. Yep. So here, I do multiple things. I'm going to configure. I'm going to configure. Not nano. I don't want to do nano. Terraform import. Yeah. So here, what I want to do, as I said, I want to create dynamic secrets. So I want to rely on the dynamic secret engine, dynamic database secret engine of Vault, and configure it to use and to have access to my MongoDB stuffs. And I'm going to do that right now by I don't go through the TF plan. I'm going to do an apply directly. As you can see, it's pretty quick. Here, I have a new secret, mongodb.conf. And as you can see here, yes, my thing changed. And if I go there, just to show you, I change that. Edit. I have to change the password. Yep. Connect. So here, that's the old one, so I can disconnect that one. So here, what I have, collection systems, system users. So here I can see now that I have a specific users created by and managed by Vault directly when I start the new pods. Just to show you and to show you what it means, if I do a dashboard. So now I do two things. Because I have a dynamic secrets, I have now the opportunity to, and I need to, use a sidecar container to do a renew and revoke of the secrets that I'm using. So here, if I go there, jobs, not jobs, votes, fruit catalogs, and I go to logs. Here, as you can see, I have the Vault in it, so it's done already. So I grab the new access to my dynamic secret database. And here I have the Vault list refresher, and every 6 minutes is gonna do a refresh and a renew of the certificate, not the certificate, of the dynamic secrets. And if I, as a pre-post command, when I'm gonna kill the pod, I have a revoke command to revoke the dynamic secret that was created by Vault. If I don't do that, Vault at the end will still revoke the dynamic secret, because Vault can manage it. Vault doesn't even can do that by default. It manages the revocation and the time to live and the lease period of the configuration. Just to show you, I still have access to my application. I'm just using something else, and I'm use grape. I don't remember if grape is only one E. Anyway, let's do Apple and United Kingdom. Yep. So yes, I still have access to my backend, so that means my dynamic secret is working, and I can have access to it. So just to finish, and it's because I spent too much time talking, as always. I'm going to go through just to show you the deployment of Consul on a configuration that we don't have time to go through the full steps. So here, what I'm going to do, the deployment of Consul and Envoy. So to do that, I'm using, the Helm chart. So here I do Helm install. Yep. Yeah. Fine. So here, what I'm gonna do, I'm gonna just deploy. Just to show you here, I have deployed Consul. And Consul Connect. And the beauty of the thing here is we don't have to do a lot of things. So here I don't have anything. I just have my Consul running. So here I'm gonna just configure kubectl apply MongoDB and kubectl apply catalog. Here, what I did, just to show you, I had some annotation inside my application deployment here. What I had to add is only this. Everything else is automatically managed by Consul and Consul for Kubernetes. So here I just have to say, okay, I want to inject, every time I start that pod, I want to inject a sidecar proxy. The sidecar proxy is Envoy. And here I want to connect to the MongoDB on that specific port. And we do exactly the same thing here on the annotation here. We use that, and we just had some configuration. And if I do a refresh, you can already see that I have everything registered to my Consul configuration. And now I can start to create intention to say which service can talk to which service. If I do that, if I do, for instance, Spring Boot to MongoDB, I say hello, say save. Now I can configure only that to give access from my front end to my backend. So in summary, what we did, we deploy a new application, not a new application, we deploy a legacy application which was not built for with security in mind. We add, as security in terms of communication for HTTPS ingress routes. We add the authentication and airbag on the application. We secure the access to secrets for static and dynamic secrets. And we add a network abstraction layer for enforcing, and for secure the communication between different services. And to do that, we even, didn't touch the codes, pretty much only for keycloak, because of obviously you have to add things when you add that. But for anything else, everything was without touching the code of the application. And I'm gonna be good. I finish because we still have nine minutes for question.
Thanks, Nicolas. You can go through the last slide. We still have time. It's fine.
Yeah, it's what we do next is start to leverage. For instance, it was Spring application. So instead of using init stuff, you can init containers or stuff like that. You can use a library specific to Spring. We have some things called Spring Cloud Vault or Spring Vault to manage the interaction directly inside the application to connect and communicate with Vault API. We can do even more regarding Consul. We can use some things that we call mesh gateways to federate at some network layers, the different OpenShift clusters that you can have in your different environment, even in different clouds. And also something else is we can extend Vault and Consul to from outside Kubernetes and for any other services that are running inside your data centers or even in your cloud. And thank you for your time. So we have some spare time for a question if you have any.
Perfect. All right. Thank you, Nicola, for the presentation and demo. So we'll go over to Q&A. As a reminder, please submit your questions in the Q&A box in the GoToWebinar control panel, and we will go through them live. So just to get us started, so we have a question. So can Consul use external PKI for certificates?
Yes, of course. So here for the simplicity of the configuration, I use internal ones inside Consul, but of course you can connect Consul to Vault, for instance, or any other third parties PKI systems to generate automatically the certificates trusted by your company to do the mutual TLS communication and verification. Okay. It's documented on our website.
Next one, do you have a Helm chart to deploy Vault?
Do you have what, sorry? Oh, yeah. Yeah. Sorry. Yes, we have a name chart. So today it's mainly supported for Vault OSS, not for enterprise yet, but we are working on it. But yes, here in my demos, Vault was external because that's the best practices today to have a Vault external to any Kubernetes systems for some security concerns. And I don't have time to explain everything here, but we're going to maybe put some link inside the webinar or the email at the end. But here I use an external Vault, but of course, yes, for dev environment, for instance, you can deploy Vault with a name chart on your Kubernetes or OpenShift systems or end user Kubernetes stuff.
Okay, great. All right, well, that's a wrap. Thank you ever so much for everyone who submitted questions, and to Nicola for answering, and a great demo as well. I hope everyone enjoyed today's webinar. Finally, as I mentioned at the beginning, this webinar was recorded, and we will make the recording and slides available within the next day or two. We'll also send an email to everyone who registered with the recording link. Have a great day. Goodbye, everybody.
Thank you. Bye-bye.